Today we're going to factor when a is greater than 1, and we're going to start with factor by grouping, and once we feel confident with factor by grouping, then I'm going to show you guess and check. Some of you will like one method over the other, but I need to show you both of them. All right, this starts out the same as yesterday. We need to find a pair of numbers whose product is AC and whose sum is B. The weird thing is, we need to find the product that is equivalent to AC. That means we're multiplying our first number, 3, times our last number, 2. What is 3 times 2? 6. Now, really, this isn't any different from yesterday. Yesterday, the number in front of the x squared was simply a 1. And so 1 times whatever that C value was would just be the C value. So this is exactly the same as how we start every factoring problem. But you need to multiply your A value and your C value. We are still trying to find that same pair of numbers. Needs to add up to 7. So what pair of numbers multiplies to give us 6 and adds up to 7? 1 and 6. That is so cool that it just likes to disappear on me. Okay, according to these steps, step 2, we are going to split our BX term into that pair of numbers we just found, so we have 4 terms total. Basically, we're taking this 7x and splitting it into 1x and 6x. Do you all agree that 1x and 6x still represent 7x? We just kind of broke it up. We uncombined the like terms. We still have 3x squared in the front, and we still have the plus 2 at the end. So we're taking our trinomial, we're splitting that middle term into that pair of numbers we found to make it a 4-termed thing. Your next step, directly after the second term, draw a line to split this into 2 groups. The first 2 terms are the first group. The second 2 terms are the second group. In that first group, what do 3x squared and 1x have in common? X. We are going to factor x out of that first group. There's a couple ways you can think of this. X times what is 3x squared, x times what is 1x, or it can be very helpful for some people to write that GCF underneath each term and divide each term by x. So 3x squared divided by x is 3x. 1x divided by x is 1. Now in the second group, we're going to do the same thing. What do 6x and 2 have in common? What could you divide out of both 6x and 2? 2. That's a positive 2. 6x divided by 2 would be 3x. What about 2 divided by 2? 1. Okay. This line is actually the distributive property fully written out in a way that we normally don't write the distributive property. The factored form is x plus 2. Does everyone see where that x and plus 2 came from? I color-coded it so that you can hopefully really see where that x and plus 2 came from. So the x in front and the plus 2 in front, that's your first set of parentheses. Do you notice anything interesting about the green parentheses? They're the same. That would be your second set of parentheses. And that is your factored form. What if those green parentheses were different? They shouldn't be different. They should be identical. If they aren't identical, you did something wrong. Go back and try to figure out what you did wrong. X plus 2. This line is the distributive property written out. If we did x times the green parentheses, that's what's written here. And then we did 2 times the green parentheses, that's what's written here. So we're just collapsing that back down into the x plus 2 and the 3x plus 1. Number 2, we're going to start the same way, on the correct page preferably. We start by multiplying our a value and our c value. So 2 times 5 is 10. We're looking for a pair of numbers that multiplies to give us 10 and adds up to our middle number of negative 11. What pair of numbers does that? Negative 1 and negative 10. Okay, second step, you take this middle term, negative 11x, and you're going to split it into negative 1x and negative 10x. Keep your 2x squared in front, keep your plus 5 at the end. Now here's the great thing about factor by grouping. If you're doing this on your own and you wrote negative 10x minus 1x, if you switched the order of those middle terms, it would still work. Your work would look a little bit different, but you would still get the same answer. Okay, next step. After the second term, split this into 2 groups. The first 2 terms are group 1, the third and fourth term are group 2. Factor group 1. What do 2x squared and negative 1x have in common? What could you divide out of both of those terms? Just the x. And some people find it helpful to put divided by x underneath each term. Because then, what's left in the parentheses? 2x squared divided by x, we're canceling out one of those x's, you would have 2x left in the parentheses. X times 2x is 2x squared. Negative 1x, divide the x out, you're left with negative 1. Okay, massive hint time. Whatever symbol is in front of your third term, use that symbol. So because there's a negative in front of that 10, use a negative. What do 10x and 5 have in common? What can you divide both 10 and 5 by? You can divide them both by 2. Okay, negative 10x divided by negative 2. Oh, you know, I'm just totally trying to lead you astray. It's cool. Not cool. By the way, that's the most common mistake. Do you see why that's a common mistake? You think 10 and 5, oh, 2. Yeah, don't do what I just did. Don't. Okay, so they have negative 5 in common. Thank you for finding that. So we are dividing both of these terms by negative 5. So negative 10x divided by negative 5 would be positive 2x. And if you didn't catch that mistake, we would have ended up with something in this green parentheses that didn't match the first one. And that would tell us, hey, we did something wrong. The next term, 5 divided by negative 5 is negative 1. By putting that negative from in front of the 10 straight down in front of that 5, that allowed us to factor out the negative, and now our green parentheses match. So, what is our first set of parentheses going to be? X minus 5. What is our second set of parentheses going to be? 2x minus 1. Try number 3 on your own using factor by grouping. Okay, we're looking for a pair of numbers that multiplies to give us negative 6 and adds up to positive 1. That would be negative 2 and positive 3. So we split this into 4 terms by splitting that middle term. So negative 2x plus 3x minus 3. And if you happen to do 3x minus 2x, that's fine. You will get the same answer. Your work is just going to look a little bit different. Okay, split it after the second term. Group the first group. What do they have in common? 2x squared and negative 2x? They definitely have 2x in common. 2x squared divided by 2x would be simply x. Negative 2x divided by 2x would be negative 1. This is honestly a common mistake. People forget to put that 1 in there. But remember, if you were to redistribute, you should go back to what you had. 2x times x is 2x squared. 2x times negative 1 is negative 2x. So you can constantly check yourself as you're going. 3x and 3 have 3 in common. If you divide both terms by 3, you'd be left with x minus 1. So our factored form is 2x plus 3, that's a weird looking 3, times x minus 1. Number 4, we're going to try guess and check. We still start exactly the same way. You need to multiply your 6 and your negative 5. So we're looking for two numbers that multiply to give us negative 30 and add up to 13. If you're thinking, oh, it's 10 and 3. Yeah, it's not. It's not 10 and 3. Because 10 plus 3 would give you 13, but 10 times 3 is not negative 30. So you might need to write a list of ways that you can multiply to get 30. It's not 3 times 10. Which one is it? Negative 2 and positive 15. Okay, I am going to draw out a factoring skeleton. Now, this blank and this blank, when you multiply them together, they give you 6x squared. What times what would give you 6x squared? 3x and 2x, probably. Now we're going to look at the outer terms and the inner terms. When we multiply 3x times this other outer term and this inner term times 2x, those two things should combine to give us 13x. This is where these numbers come into play. We need to put negative 2x in one of these spots and we need to put 15x. Now think about it. 2 and 15, can we do 2 times something to give us 15? No, so I'm going to put the 15 with the 3. I'm going to put 15x on the mouth of this little face-looking thing. And I'm going to put negative 2x on the nose of this mouth face-looking thing. And now this is a puzzle. Fill in the missing pieces. So 3x times what would give you 15x? 5. So plus 5 goes there. 2x times what would give us negative 2x? Negative 1. There's your factored form. 3x minus 1 times 2x plus 5. For guess and check, you start the problem the same. 3 times negative 6 is negative 18. We're trying to find a pair that multiplies to negative 18 and adds up to 7. You might have to write down your pairs. It is negative 2 and 9. So if you do your factoring skeleton, first you need to think about the first blanks. The first term of each binomial will multiply to give us 3x squared. What do you think those blanks are going to be? 3x and x. 3x times x will give you 3x squared. Then think about it strategically. Should we put the negative 2 on the little arc associated with 3x? Probably not. We should put the negative 2 on the arc associated with x and the 9x on that bottom arc. And now fill in the pieces. 3x times 3 would be 9x, and x times negative 2 would be 3x. There's your factored form. Number 10 is like the difference of two squares from yesterday. Yesterday we did a problem that looked more like x squared minus 81. Today we're going to do 4x squared minus 81. 4 is the perfect square of what number? 2. X squared is the perfect square of x. 81 is the perfect square of 9. Your factored form is 2x plus 9